Hey, I'm Melissa.
And I'm Jam.
And I'm a chemist.
And I'm not.
That part makes me laugh every time. And welcome to Chemistry for Your Life.
The podcast that helps you understand the chemistry of your everyday life.
Jam, do you want to hear about what you're going to learn today?
More than anything in the world.
Today we're going to talk about how microwaves work.
Whoa.
I'm so excited because last week sometimes I don't bring my lunch. And then Jam and his wife provide me with food. And so last week after we recorded, we were heating up ramen noodles. Don't judge us. They're really good.
Yep. Very good. And good for you.
I'm not sure that they're good for you.
I think they are. If you don't look at the nutrition facts, then they are.
They're good for your soul.
Yeah.
And for your nostalgia.
Yes.
Growing up, I had ramen noodles and Dr. Pepper like every day for lunch in the summertime. I love Dr. Pepper. Okay, so I was watching you heat up your ramen noodles, and I started to say, do you want to know how? And then I realized that was the premise of this show, and I couldn't just start telling you science outside of it.
Yeah, it was like I can't remember how that came up either, but there was a moment where I knew that you were then immediately consciously holding back information. And I was like, dang it.
Ever since then, I've been like, I can't wait to talk about how microwaves work.
Yeah.
So we're going to talk about how microwaves work today. You're going to learn that. I'm going to explain if you've ever noticed that little plate inside the microwave doesn't get hot, but your dishes do.
Yeah.
We're going to talk about that.
Oh, gosh.
And then you're going to explain it all back to me.
Okay.
Okay, so that's what we're going to do today.
3 easy steps.
I'm so excited. I think it'll be very fun. And I've been waiting literally one whole week to tell you about it. Okay, so before we do that, though, how has your week been?
It's been pretty good. I roasted a lot of coffee this week, which, like the amount of coffee I roast in a week and a measurement of how happy I am, those are very correlated. And to try to put it scientifically. And I started, like, putting a lot more intentional effort into job hunting.
Nice.
I've been in between things and trying to get a grip on life a little bit, but trying to see what's out there and send resumes and applications and stuff and just kind of see what happens.
Nice.
So yeah, it's been good. It's, it's weird because I don't know what's going to happen, but
kind of exciting.
Yeah, a little bit.
The unknown's exciting.
Yeah.
And in the meantime, your full-time job is to podcast and hang out with me, right?
Podcast, roast coffee, hang out with you, drink coffee that I roast, and try to sell stuff and clean out our garage and household stuff. Be a stay-at-home dad, even though we don't have any kids.
I think that's just called the stay-at-home husband.
Oh, yeah. We have dogs. So what about you? How's your week been?
My week's been good. I could talk about all the good things that happened, like how I saw all these friends and people that I love, but instead I'm going to tell you about the bad thing that happened. Because
that's the thing that sticks out more.
And it just happened. So yesterday at around 5 o'clock in Texas in the summer, it dawned on all of us that our AC had broken.
Oh, no.
It dawned on me and my roommate, Ryan. We were home. We thought it was the batteries for the thermostat. We replaced them. Then it just kept getting hotter.
Oh, no.
It was terrible. So last night I learned something new about myself through this experience. I thought I hated wind being on me.
Yeah.
So I was like, this is just going to be terrible. I'm just going to have to put this giant wind tunnel fan that I stole from Sarah Glennesque 3 years ago facing on me and just sleep that way. And I woke up so often because like the little hairs around my face were tickling or I was getting blasted in the face, depending on which direction I was laying. It was terrible. And then I realized I could move the fan to where it blew on my body, but not on my face.
And then you're actually able to sleep.
And then I was able to sleep.
Yeah.
And that's when I realized that it's not that I hate wind on me. It's that I hate wind in my face.
Interesting.
I also hate water in my face. So apparently it's just like fluid in my face of any kind.
Or just like you just don't want things in your face that you're not used to having there.
Maybe. I don't know. Other people don't mind it. I like avoid getting my face wet in the shower.
Huh.
And I don't put my head underwater if I can help it when I'm swimming.
Interesting.
I hate it. So that's a little inside fact about me that I don't feel like many people know.
Yeah. Hopefully no one decides to use that against you.
They could. I think
they just run up to you and they like have a fan. They're like, hey.
I would be really mad if someone did that. Okay.
So microwaves?
So microwaves. Let's get into it.
Okay.
Do you know at all how microwaves work?
I don't think I do.
Yeah. Well, I learned when I was in grad school, and I have looked up some things to fact check this. I can't find this explicitly stated anywhere in a textbook, but it seems like the most logical explanation. My professor taught me in my analytical chemistry class, shout out Dr. Verbeck, about how microwaves work. So ovens, regular ovens, not microwave ovens, they just get hot.
Yeah.
They just get hot, and then so your food also gets hot because it's in an environment where heat's being put in. Microwaves don't do that.
Yeah.
They work by only heating up water particles in your food.
Okay.
That's it. That's how microwaves work.
How can they only heat up water?
I'll tell you. I'll answer that question.
Okay.
But before I answer that question, I want you to think through some of the implications of what it means that it only heats up the water particles.
Okay. It only heats up water, so that's really good for food because so much of our food has some type of moisture in it. I mean, probably everything we eat has some amount of that.
So what if there's not very much water in it and you're heating up the water that's in it?
Would that water get really hot really fast because there's not very much of it?
Well, it's not necessarily that it'll get really hot really fast, but some of the water always heats up enough to turn into steam. So you're losing water and moisture.
Got it.
So have you ever reheated chicken?
Yes. Oh, yeah.
And it dries out.
Yeah.
The key is to put more water on there.
Got it. Or just to go ahead and reheat it in the oven.
Yeah, or just reheat it in the oven. That's fine too. So because it only heats up the water particles, it can dry food out because some of that water will evaporate every time.
Okay.
And that means if there's any water in your dish that has absorbed into the surfaces of your dish, that your dish is going to heat up too.
Okay. Interesting. Because there's some bowls or dishes that get way hotter than others. And it's annoying because it's dang it, why is this molten hot?
Yes. So it probably is made from a cheaper material or it doesn't have as good of a seal on it. So it has absorbed moisture and then you're heating up that moisture.
Okay.
So that is why that happens.
Yeah.
Can you think of why the plate inside the microwave never gets hot?
Is it because if you're doing it right, it doesn't touch the food at all and doesn't have moisture in it?
It definitely doesn't have moisture in it. So they make it in such a way that there's no moisture and it's not going to absorb moisture.
That's pretty crazy. Dude, I have a story about this.
Okay, tell me.
One time, when I was a kid.
This is unexpected. I'm excited.
Our microwave plate, that glass one, that's the revolving, exploded in the microwave.
Serious?
And by exploded, I mean, as a kid, that's the memory I have of it. It probably just cracked really loudly into several pieces. In my mind, it was what the heck? It added to the mystery of microwaves. But I'm guessing it's possible there maybe was a nick in it or something like that. And then it was able to get some moisture in there. And then because the rest of it couldn't, it was this super imbalanced thing going on.
Yeah, I don't know.
It was very... And then we had that microwave for a long time. We didn't have a plate. And
you just
kept
didn't
using it.
Or did you put the bowls or whatever right on the revolving thing without a plate to balance it?
I don't know what we did. Now that I think about it, we still had the microwave for a long time, but I don't know how we managed that.
Well, so now you know the basics of how it works. Isn't that amazing?
Yeah, that's crazy.
It's amazing to me that they figured out how to make plates that would never get hot in the microwave.
Yeah.
Also, why don't we just have all our dishes like that?
Yeah, that would make a big difference because, I mean, seriously, it's a regular thing where I'm okay, I have to get a pot holder just because I'm a little bit scared about how hot this thing's going to be.
Right. I assume that there's some other drawbacks to having that kind of dishware, but maybe it's very expensive or something, but it seems like it would be worth it. I do have some dishes that I don't feel heat up as much.
Yeah.
But that one, there's no heating.
Yeah.
Okay. Now you know that. Now you know the basics of how microwaves work. You could leave with that if you just wanted to.
Okay.
But I want to answer the question, how do you only heat water particles?
Yeah, because that's like, for me, I feel like, okay, now I know what is happening to at least the food part, but I'm still like, how is this insane piece of technology doing this magic? Like, it is kind of weird. Like, it makes sense that maybe people were a little bit standoffish toward the microwave when it first came out, because it is like hey, just stick this in there and press some buttons and don't worry about it. Don't ask any questions. It's just like,
don't worry about it.
Yeah.
Just stop. Don't. It's not worth it. Don't ask.
It's just using waves, okay?
It is using waves. That's true. Okay, so there are speaking of waves, that was a good transition. It's kind of impressive that you said that, not knowing what was coming next. There are lots of different kinds of waves.
Uh-huh.
So, and you've heard of them. They're ultraviolet waves. That's UV. That's what gives you sunburns. Radio waves. You've heard of those. Visible light. That's waves, like the light that we see is waves. And microwaves are waves. So they're waves with different amounts of energy, different wavelengths, and they sort of fall into these categories on a scale.
Okay.
So every single molecule will absorb in certain ranges of those types of waves.
Okay.
Not those exclusively, but they'll absorb different amounts of energy based on the type of molecule they are. And that has to do with the shelves that we talked about briefly in our Q&A episode, where if you have different abilities for electrons to move up and down on different energy shelves, is the best way I can think of it.
Yeah.
It will absorb different amounts of energy to move that electron up and down.
Okay.
Okay. Absorb, move it up, let off energy to come down. So every molecule will absorb in a particular type of wave, is the best way I can describe it in the time that we have. So water has a nice broad absorption in the microwave region.
Okay.
So it can absorb microwaves, whereas other things maybe won't absorb microwaves.
Got it. So just before the microwave piece of technology existed, water as a substance just already can absorb microwaves, not
Yes.
not necessarily created by like some machine, but just it already is the case.
Right.
Okay.
So microwaves, the waves, not the box, existed, and we knew that water absorbed. I don't know how they invented microwaves, but I'm assuming they knew that water absorbed in that region.
Yeah.
And then they thought, hey, what if we create a box that emits microwaves in a contained environment and heats up water in food?
Yeah. Okay.
Can you think of something that doesn't absorb in the microwave region that might cause problems if exposed to microwaves?
Like metal.
Yeah. So metal will reflect that instead of absorb it. And then it will cause those electric sparks between the metal spoon or whatever and the walls of the box and can burn holes in it. And that's why metal will, quote, explode in the microwave.
Yeah.
Because it's reflecting those energy things and putting it into a pattern that it wasn't expecting and causing sparks of electricity.
One time, my friend in third grade was heating up some... I've got a lot of microwave stories.
Yeah, this is crazy.
He was heating up some tortillas, and he accidentally left the twist tie on. And it was classic because it's like, it's metal, but it's surrounded by like pretty much like paper. I think that was like one of the cheaper twist ties, so it was like paper.
Right.
So it just started burning. It caught on fire, though. Yeah.
That is so funny.
His lunch suffered.
Man. Yeah. Did the microwave suffer?
I think he caught it in time, or a teacher did, or something like that. But,
Okay.
Yeah.
So that's it. You got it. Now you should know enough to be able to explain to me how microwaves work. Do you have any questions before we move into the You Teach Melissa portion?
Maybe it's not chemistry, maybe it's like electronics or something, but how does that box of microwave create microwaves? Like, is that something, you know how that happens, or is it?
I don't know.
Okay.
There's a thing inside the microwave that generates microwaves.
Okay.
But I'm not sure how. And I think that would be chemistry. It would be somewhat interdisciplinary because
Yeah.
a lot of waves and energy stuff is physics, but it's also important to know to understand chemistry, like why things absorb in these regions. And we use that technology, that absorbance technology, in a lot of things. That technology is key to the research that I did on solar cells before I was working on my master's. Okay, now can you explain it back to me?
Okay, I'll do my best. So
I love this part because I'm just going to drink my cold brew.
And I ran out of coffee, so I don't even have anything to drink.
Well, that's okay because it's your talking time and my listening.
Okay, I need to focus. Don't think about drinks. Okay, so food has... I'm going to start from the user side. I'm thinking like, I've got some food. I want it to get hot, all right? So food, the good thing about it, in this case, is that a lot of it has some amount of moisture in it. Some of it has a lot in there.
Like soup.
Like soup is like, almost more moisture than not. So, so you put it in the microwave, and water already, just like the basic water without thinking about it being part of a bowl of food, already absorbs microwaves. That's right. Okay. It's already true that that's the case based on like just the waves out there in the world that can happen from things like ultraviolet and the other ones you mentioned.
Right. And all those waves, I forgot to say this earlier, I think, but it's called the electromagnetic spectrum. That doesn't really matter a ton, but you might remember that from high school or physics or whatever, that there's a spectrum of waves and it's called the electromagnetic spectrum.
Okay, yeah, that does sound familiar actually. And so water already just absorbs and responds to microwaves. And so when you take it into the context of food and how much water is in a lot of food, if you can have a thing like a box that can pump out a lot of microwaves, then it would, the water in food would respond to it and heat up. That's just like the natural response of water to...
It's not that it's responding, it's just that it's taking in energy, and as it's taking in energy, it heats up.
Got it.
Those waves are energy.
Yes. Okay. Yeah. Energy has to happen somehow, and in this case, it's waves.
Yes.
Okay.
So the waves are causing the molecules to heat up.
Yeah.
As they're absorbing the energy from those waves, they begin to heat up.
Got it. And the things in the microwave that aren't getting hot do not have moisture or have like some, like are made of material and then also sealed or whatever, so they don't like really take in any moisture. So that ideally just the food is what's getting hot.
Right. And I believe with those things that aren't reflecting waves, those microwaves are just passing through and it's not causing any harm. No absorption, no reflection, just passing on through.
Okay, yeah. And one thing you said that I thought was pretty cool is that it's actually okay and very good to put metal things in the microwave. Like that was really new information to me.
Yeah, that is what I said. That's exactly right.
I'm really excited to make lunch now.
Yeah, and I think that maybe reflect isn't exactly the right word. That gets into a little bit more of the physicsy side of things, but the important thing to take away is that water absorbs the energy from microwaves and heats up, and metal can't do that same thing.
Yeah.
It's not interacting with the microwaves in the same way.
Yeah.
That water interacts with microwaves and absorbs them and heats up in a nice, positive, safe way. It does something crazy.
Yeah. And then there's the things that are in the middle that are like neutral because they're not metal and they're not water.
Yeah.
At least in the very simplified categories that matter to most of us.
Right.
It's like the plate. It's like, okay, it's going to be fine. It's not a big deal.
Right. Exactly. So you got it. That's it.
Man, that's awesome. Gosh. That one's cool. I'm excited about microwaves. I mean, they're still a little freaky, but it's in a cool way.
It almost is as if you're taking UV from the sun, only instead of UV, it's microwaves, which people don't think about microwaves for whatever reason in the same way they know about UV waves or radio waves. They don't. Everyone just thinks microwaves are the box. They don't realize that microwaves are waves. But it's basically harnessing this special type of wave and using it exactly the way you want to.
Yeah.
It's pretty cool. It's pretty powerful. Again, scientists have superpowers.
Yeah, that's definitely superpower.
They can harness the world's things and use it to their will, bend it according to their will.
I mean, think about if that was a superpower that a hero had was just like microwaves. Like how crazy would that be?
You point your hands and like I imagine out of your little fingers comes little waves.
And wouldn't that be pretty damaging to a person if you like say like I would like
absolutely. There's lots
hand.
of water in people.
Oh yeah.
That would absorb that. Also, I forgot to tell you, I think this is so cool and also a little bit like a superpower.
Uh-huh.
I learned this on an episode of Radiolab. It was the first podcast that I ever loved.
Mm-hmm.
It's such a good podcast. It teaches you so much about science. There's
I also love it.
there's a creature called a shrimp. What is that? A mantis shrimp that has way more cones in its eyes than humans do.
Yeah.
I'm not going to get into this, so go just listen to that episode. But they have theorized that that little guy can see waves other than what's visible to us.
So not just other visible light waves, but potentially maybe like microwaves or radio waves or something like that.
We've defined visible light based on what we can see, but
Yeah.
it's possible that other waves are visible to him, to this mantis shrimp.
Yeah.
All of them.
Him or her,
them, all of them. It's possible that they can see more than we can see. So they could maybe see the near IR waves and the ultraviolet waves, and they could see more than us possibly.
Yeah.
Isn't that crazy?
That's insane. I
Yeah.
also listened to that episode, and now I need to re-listen to it because it's been a while. Mm-hmm. But gosh, that's fascinating.
Yeah, so mantis shrimp and scientists have superpowers.
Wow.
Is the big takeaway. Thanks, Jim, and all of you out there listening for learning about microwaves and science some more today.
And just like microwaves, Melissa and I have a lot of ideas about topics of chemistry and everyday life, but we want to hear from you of ideas that you have. If you have questions or thoughts, you can reach out to us at Gmail or on Twitter, Instagram, Facebook at Chem for Your Life. That's Chem, F-O-R, Your Life, to share thoughts and ideas about future episodes. And you can also respond to previous episodes. Mm-hmm. And if you enjoy this podcast, you can subscribe on your favorite podcast app. And if you really like it, you can write a review on Apple Podcasts. That can help us to share chemistry with even more people.
This episode of Chemistry for Your Life was created by Melissa Collini and Jerem Robinson. Jerem Robinson is our producer, and we'd like to give a special thanks to A. Kiwasong, who reviewed this episode.